Hi, my name is Aditya, and in this video we will be designing Instagram. Instagram is a very popular photo sharing application that allows users to upload pictures as well as view pictures of users they might be interested in, such as celebrities or their friends. Before we get started, let's first list out some use cases of our system. So here we have our user, here we have our system. First, in order to use our system, a user has to be able to log in. So that can be one use case. After logging in, users should be able to upload pictures. So that will be another use case. So they can upload. Users will also have the ability to follow other users. So we will have following here. Users will have the ability to view pictures. So viewing comes in a few forms. So one way we can categorize viewing is by viewing their own timeline. So their own timeline meaning pictures that this user has uploaded to Instagram. So let's write it down here. So we have viewing, and we break it down into a user timeline, which is what we'll call it. User timeline. Okay. We can, and now, in addition to viewing their own timeline, users will have the ability to look at their own timeline, meaning a feed of pictures from all the other users that they're following. So, for example, if this user A is following 100 other users, user A's home timeline will have pictures from all those 100 users ranked in some format and presented to user A. So this is home timeline. And the last one we'll talk about is just browsing. So browsing meaning the user goes into the search bar and the user can look up topics that they're interested in, pictures related to those topics. Perhaps they're looking for the username of their friend. So that will be the browse use case. So this is just browse and search. Before we go into these use cases, first let's think about how we can model the users in our system as well as the images in our system, and the relationship between one user, between multiple users. So to get started, let's first look at how we can model just a single user. So here we'll have a user. A user will have few attributes. So a user will have an ID. This ID will be unique to this user in our system. We can store the user's name, for example. We can store the user's last login. We want to store this last login because it will help us when we implement the home timeline use case. So we have ID, name, age. Let's leave the list of attributes open, but here's a few of them that we'll store. We'll also have images. So let's define the attributes on images. We'll have an image ID. So this image ID will be unique to this image in our system. We'll have a user ID. So each image is associated with one user. So this is a one-to-many relationship. So we can say this is a one-to-many, like that. We'll store a date. We'll store a location as well. So here's how we can model users and images, and there can be other metadata as well about users and images in our system, but for now, here's a few of the attributes I've written down. So now we've represented users in our system, we've represented images in our system. Let's think about how we can represent the relationship between multiple users. So in Instagram, a user has the ability to follow other users. So we have to somehow represent this relationship in our system. One way of doing this would be to having a mapping where we have a user ID that maps to a list of IDs. Okay. So what this means is that if we have, let's call this user A. So this will mean user A would be this ID. And if we have a few other, example users like user ID B, C, and D, what this represents is that A has B, C, and D as followers. So that's how we can represent who is following A. We also need to have a way to represent what images are are associated with what user, and this is helpful in defining our user timeline. So let's talk about that. So for the user timeline, we'll have a similar mapping. So we'll have ID, and this will map to a list of image IDs. So what this means is that user ID A has uploaded, let's say we'll call it like image 1, image ID 1. So I'll just call it I1, I2. So I1 and I2 are images of user A. So whenever user A pulls up their own user timeline, they should see image number 1 and image number 2 on their timeline. So in Instagram, the way images are presented is based on reverse or descending order by date. So that's actually why having this information, this date, is useful, because what we can do is just pull all the images. So if this model was in some sort of relational database, we can, based on the user ID here, we can pull all the images with user ID A, sort by in descending. We can get all these IDs, and once we have all these IDs, we have the ability to pull to get the pictures and then show them to user A. So that is how we can solve for use case 1. So that's the user timeline use case. So one improvement, or one thing we can optimize is that we can keep all these IDs in memory, because they're not, their values are known. It's not going to change over time. Like if a user has 6 images or 7 images that they've uploaded, all we have to do is just add the 8th image to the top of their feed, of their own user feed. So querying our database repeatedly is wasteful. So if we just keep a store of the user, the image IDs for this user in descending order by date, we can solve for this use case. So we've talked about how we can do the user timeline. Let's talk about the home timeline. So for the home timeline, as we mentioned before, this use case is when a user wants to see all the pictures from all the other people they're following. So if we go back to our example here, we have user A. User A might be following 10 people, for example. 10 people, and we have to populate user A's timeline based on all the pictures from all the other 10 users that this user is following. So we can do a similar query that we were doing for the user timeline. to generate to get all the pictures to show to user A for their home timeline. So to be able to do that, we would have to first say, okay, so to be able to do that, that structure is not represented here. So another mapping we could have is from user ID to, let's say, user ID to list of people they follow. So this would be A, and if we say A follows, let's say that like we can represent relationships like downward. So A follows, for example, B like this. So we have user B, we have user C here. So we can say A follows B and A follows C. So we can do this. So we have A follows B and A follows C. So if we have this stored, we can then do a similar lookup for, hey, let me get all the images that user B has uploaded based on our table or our model here. Let me look up all the images that C has uploaded, and then based on some ranking algorithm or procedure, we can order those pictures and show them to user A. So that's one approach. One approach in displaying that timeline for user A. Another approach we can think about is going back to the idea where we look at this first values, the store I was talking about, where this is user A, and they're and these guys are the followers of user A. So what I'm getting at here is, instead of having a pull-based model where we're continuously, whenever a user uploads their or wants to view their home timeline, instead of pulling all this information based on this mapping, we can do a push-based model where whenever someone posts a picture, that post is pre-populated for all the it's pre-populated for all the timelines of the people who are following that user. So let me explain that with an example. So let's go back to this where we have user ID A, and these are the followers of user ID A. Okay. So now let's say that user ID A posts a new picture. So he posts a new picture, and that information has to be propagated to user B because, as I mentioned earlier, B follows A, C follows A, and D follows A. So what I was getting at here is that we'll have yet another store where we'll have B will have a list of B's timeline will have a list of pictures. So this will be the home timeline. So this will be home timeline. Okay. This will be the home timeline store. This was just the previous model where we're storing who this person is following these people. Okay. So for the home timeline, what I was getting was that as soon as A posts, that information will be given to B's home timeline mapping. So here we can just say, hey, let me put I3, image ID3, which we're assuming that user A just posted image number 3. So that gets put here. And then what happens is that instead of doing first figuring out for each user figuring out, hey, let me look at for B, let me figure out what picture to get to put in A's timeline. Then for C, let me figure out what picture to give to user A. In this method, we're already giving out or populating image IDs that we need instead of doing that for each user that user follows. That makes sense. So doing it this way, we'll have each user here. So B will have their own home timeline mapping here. C will have their own. D will have their own. So that way, whenever B, for example, opens up their home timeline, the system knows that, hey, I only need to get image 3, image 4, image 5, and show that to user B, user C, and user D. So let's think about what are some of the downsides of doing this. So one of the downsides of doing this would be that if A over here, for example, happens to be Miley Cyrus or some really big celebrity, this list of IDs will be, it's going to be a site like a large amount. It could be 100, it could be 100,000, 200,000, or even millions. The size could be in the millions. So doing this propagation where we're saying, let me push all these like IDs into all my followers' home timeline mappings won't be efficient. So we could to tackle this, what we can do is have a hybrid approach. So for each user ID, right? Each user ID we'll combine the pull and push based model. So we'll use the push based model for users that are that don't have millions of followers, but we'll use the pull based model for users that have a high follower amount. So let me give an example of that. So let's say we have let's look at user B, for example. So we had B over here. So let me write here. So we have B. And in this store, what we'll have is all the users that B follows, except the users that are high profile. So let's say we'll say user follows C, and user follows C, and let's say it also follows A, right? But A is a high profile. A is a high profile user, so we will not have A in this, or I misspoke. We'll only have A in this. Actually, that's what I meant to say. So we'll only have user A here, because this is a high profile user. But C and D will have this model that I talked about. So C will have. So this would be C has B and D has B. Right. So what this means is that this is going back to this model where we have user ID to followers. So user ID to followers, user ID to followers. This is saying, and this one is different from these two. So let me define that. So what I was getting at was that whenever user B opens up their home timeline, user B will do this pull. We'll do this pull for user ID A, because that user ID is a celebrity or a high profile person, but for example, user C and user D, which user B is also following, that information will just be that'll happen via the push based approach. So to give the final design of this, right? So this is saying, let me just write this down. So this is user to follow. So this is saying this user follows these people. This will be user to followers. This would be users to followers. So we have that, and then in the final timeline, what we'll have is that we'll have, so for example, B, so this is the timeline. So what we'll have is B will have let's see, we have user to follower, right? So the user might have, let's say C1, meaning a picture from user C, user this, then the user will have, let's say, D1. And now for A, what will happen is that as soon as the user wants to view their home timeline, we'll have to do the joins I talked about earlier, but it'll just be for user A. So as you can see, the size of this list is it's small. So that'll be efficient. So this approach combines both the pull-based model as well as the push-based model. Okay, so now we've talked about how the user timeline will work, how the home timeline will work. We talked about following as well, and it was kind of interweaved in here because to generate the home timeline, we actually had to address following. So we actually talked about this as well. So now let's talk about uploading. So in a system like Instagram, users typically read, meaning they're viewing pictures or reading from the application more than they're uploading. So one architectural choice that we would want to consider is splitting out this viewing from uploading, so that users are able to users have a dedicated way to upload pictures, because that will take a longer time and it's more computationally expensive as opposed to viewing, because that's happening at a much higher rate. So that's one decision that we might want to take. In addition, another thing we want to think about is that how these images are being stored. So we haven't touched on that yet. So one way we can store these images on using a CDN. So the actual image would be, whenever an image is uploaded, it's dispersed out to many other locations to decrease the latency of accessing that image when a user wants to be able to read it or want to view it. But the catch there is that if you have millions of images that are being uploaded, it would be expensive to store all those images in a CDN. So we should think about a way to figure out what images are most likely to be accessed more often and store those in the CDN, and then have the other images just being stored in a file system somewhere else. And there are various ways how we can think about that. We could look at just the access patterns of what images are being accessed the most, and store those in the CDN. And then as the access patterns change over time, we evict those from our CDN and then place new images. We can also take into consideration, for example, the time of the year. For example, if you're near certain holidays or certain events or landmarks in the year, people will want to look at, for example, Christmas pictures more if it's near the Christmas time. So that's just one example of how we would have to design a policy to address that. So that's a very broad overview of how we can approach designing Instagram. Thanks.